Coral reefs are called the rainforest of the sea. They shelter marine life, protect the coastlines, and support entire ecosystems far beyond what we can see from the shoreline. Their impact is enormous, but their decline is often almost silent. When people think about reef destruction, they think about what is visible in the end. Bleached coral, dying ecosystem, and biodiversity loss. But that final image hides a deeper truth. Reef collapse does not begin when coral turns white. It begins much earlier in the water itself. So, what did we almost miss?
Before reefs begin to fade, the ocean leaves clues. Subtle changes in temperature, salinity, pH, turbidity, and dissolved oxygen can all point to rising environmental stress. But too often, monitoring those changes requires systems that are expensive, difficult to deploy, or too limited to provide localized, real-time awareness. That's the problem we built the SENS pod to solve. The Submersible Environmental Network System, or SENS pod, is a low-cost, two-part smart buoy system designed to monitor reef-adjacent ocean conditions in real time. The system consists of two major components, the surface buoy and the submersible payload. The surface buoy houses the floating structure, winch mechanism, power system, and onboard electronics, which are centered around an ESP32 microcontroller and powered by a solar-assisted power bank. The submersible payload clears the pH, turbidity, temperature, and salinity sensors, and can be lowered to variable depths with the winch system for a more complete profile of reef conditions. Both components are sealed with silicone sealant and hot glue, and collected metrics are transmitted wirelessly via Wi-Fi alongside GPS location data for real-time monitoring.
These measurements are continuously collected and transmitted to our software platform, where they are transformed in their raw sensor values to something much more useful, a coral reef stress risk score. A lot of monitoring systems either stop at raw data collection or are too expensive and specialized to scale broadly. SENS pods combines hardware sensing, real-time environmental monitoring, geospatial visualization, and a lightweight predictive intelligence to one accessible platform. Each pod appears on the dashboard as a color-coded marker, and clicking it reveals live readings, trends, and current reef stress scores. SENSPod uses a dual modality approach, combining real-time local sensor data with broader NOAA environmental data to capture both local reef conditions and a larger regional ocean patterns.
Our prototype shows that a compact sensor-based floating system can be built as a real hardware solution, not just a concept. And because the design is modular, one pod can operate alone, while multiple pods could eventually be deployed as a wider reef monitoring network.
Coral reefs don't all fail at once. They send signals first. SENSPod was built to catch those signals, translate them into insights, and turn awareness into action. Because protecting the ocean starts with listening to it sooner.
I'm Aditya.
I'm Pranav, and this was SENSPod.